Welcome back to a lecture series on hydrogeology. So in this lecture now what we are going to discuss about the water quality parameters. Water quality parameters with respect to various uses like the application in terms of drinking, domestic, and how water quality parameters are required for agriculture, and what are the parameters to be considered for the industrial uses. Of course, this is the application part which is highly required in all parts, like when you take water or when you use water for agri and when you use water for industry. And normally we do, once we collect the water, we take the samples in the field and we test few analysis like AC, pH and temperature over there, and then bring back to the lab in 24 hours. Normally the analysis are carried out with respect to the major is concerned, and for minor and trace it takes little time. And then, so now we will see that what are the parameters mainly considered for the said issues. Pure water, usually you know that pure water is never available in nature. You cannot say that this water is 100% pure unless if it is processed. Once if you process, and then you will be able to get your pure water. In nature it is not available. Normally the rainwater doesn't have any impurities. The rainwater doesn't have any impurities, no impurities. But you know that when it falls immediately on the atmosphere, it gets interacted and then with the gases, gases in the atmosphere and other fine dust particles in the atmosphere. Once if it gets interact with the gases and the other substances like dust, automatically the quality of water will change from the normal natural water to the that adding gases or adding other fine particles into the water body. And then if it falls in the surface of the earth, it started get flowing on the surface of the earth. What happens, it normally interact with the soil, it interact with garbage, sewage, pesticide and other human and human and chemical waste. So normally what happens, once it falls, it started getting interacted with many parameters on the surface of the earth. So in turn the quality of water is gets changed. And when it is started traveling into the subsurface, that is the third point. What will happen? The suspended particles are the small fine grains. It is acting as a filter. So it normally takes away a few of the dust particles which is coming in the water, few of the gases or few of the other pesticides. So it gets interacted with the ground subsurface material, and then water becoming that little bit good. But what happens on the other hand? On the other hand, it started interacting with the minerals when it is passes through the subsurface, or the salt which is passes. So normally the groundwater is controlled by the geogenic sources. It means the lithology or the rock type, what it is in that particular area. It travels. It's not travel. It is automatically gets that interacted with that, and then moving down to the surface to reach the water table. And drinking water, when you say drinking water, it is depends upon the physical parameters, it depends upon the chemical parameters, it is also depends upon the biological parameters. Certain constituents are necessary for the drinking water at certain level. Let us see one by one. The drinking water should be uncontaminated, free, otherwise you will not take. Or but by looking at the glass itself, we decide that we are going to, because every human being will look at the water. If the water is that looking color, all the properties, it has to be checked. If it is contaminated, nobody will take. If it is contaminated, then it becomes poison. So normally most of the diseases, more than 60% which is coming through the waterborne disease. So drinking water is very very important to take water. How look at the child, how it takes water classically. And the other photograph, when you take the water from the tap, this is also we'll have to take care of it. Drinking water quality is a relative term. It is a relative term. It relates to the composition of water with the effects from natural process and human activities. That's what in the first slide we said. Its interaction with atmosphere, its interaction on the surface and off the surface. Determination of drinking water quality arises when the chemicals are introduced into the water. So that is very, very important. Then it becomes, change in the water quality characteristics. Access to the safe drinking water and sanitation is a global issues at present. Yes, chemical characteristics of water is a global issue. Quantity and quality has to be, that the demand is increasing, and then people are predicting that in the future, many of us are not going to get a water. Maybe it is true that we'll have to be very conscious about the saving water. And then the quality of water is controlled not only by that, it is also controlled by the anthropogenic activities and physical chemical causes that changes the quality of water. It is affected by the increase of anthropogenic activity and any pollution either by physical and chemical causes. So water quality will change. Chemical contaminations occur in drinking water throughout the world, which could be positively threatened to the human health. That's what I said. Third World War may come because of this water and its quality issues or quantity issues. Normally, we test the water quality index. It was proposed by Horton in 1965. He has given a formula for assessing the water quality. This is the usual method by selecting the parameters. The water quality index will give you method follows three steps, which include selection of parameters, determination of quality function for each parameter, and aggregation through mathematical equation. This is the mathematical equation. SLI is nothing but the sub-index of the ith parameter, and n is the number of parameter. How many parameters you are going to take? N is the number of parameter over the ith parameter. You will have to take I, and then I is equal to 1. So when you apply this formula, you will be able to get, and then you classify the results into 5 classes as excellent, good, poor, very poor, and suitable. This is the grading of the water quality index result. And based on that, World Health Organization in 2012 to 2011 and Bureau of Indian Standards in 2012, they have given for set of standard physical and chemical parameters what is the limit they can use. Highest is desirable limit and maximum permissible limit. Highest disabled, maximum both. Look at that, it is almost the same. Few parameters slightly varying. So pH, if you take up to 6.5, we can use. That is the maximum. Highest desirable, and maximum in case if you don't get, if it is slightly high, up to 8.5 you can use. So this is the limit for both WHO and BIS. And for total dissolved salts, it's represented in ppm, milligram per liter. It is between 500 you can use, it is very good, well. And suppose if it you can also use up to the maximum of threefold time, 500 to 1500. And what Indian standard says that, even you can use up to 2000. So what happened to the causes if it exceeds pH, cause in skin, cause in eye, cause in mucous membrane irritation and water system. What will happen to the TDS if it is high? You will get gastric issues will come in your intestinal irritation, bad taste, you feel odor and color. These are all the issues with respect to the higher TDS in the water. And magnesium is between 50 and 150, 30 and 100 suggested by BIS. And this is the problem that for diarrhea, abdominal, that cramping and all. Why this is coming? It is because the water may be rich with magnesium. Then if water is rich, then you will have to find out as a geologist what is the reason behind the enrichment of water in terms of magnesium is concerned. And similarly for potassium, you can use up to 12. This was given by WHO in 2011, whereas we don't have many limitations to use the potassium. And what will happen? This will lead to ingestion, acute ingestion, and bitter taste. This will lead. And potassium, maybe you can use up to 200. There is no limiting with respect to our standard in Indian standard. And you see that this leads to change, delectable taste, high BP. This will be the cause behind high BP, heart attack, and stroke. So normally, if you take not with one time, if you take over the period of time, if the sodium rich water, then this will be because of higher BP, heart attack, and stroke. And you see the cause behind the health issues are more if we are not following the drinking water standards. And bicarbonate, there is no limits are suggested, but the issues will come in case if you take higher amount of bicarbonate, that is aesthetic problem and kidney failure. And similarly for chloride, chloride between 200 to 600 and 250 to 1000, it's salty taste, deterioration of ergoleptic properties also will come. And in sulfate, if you take ppm, 400 is the limiting value. Between 400, less than 200 also we should not. Yes, up to 400 you can use, 200 to 400. Luxative effect in case if you take higher amount of sulfate. Similarly, for nitrate, around 50 and 45 is the limit suggested by WHO and BIS. Disease like cardio related issues and blue baby syndrome. Again, you feel a headache if you take continuously nitrate rich water, and fatigue issues also will come. Fluoride is suggested with 1.5 is the maximum limit, and then the cause behind the enrichment of fluorosis will come. And total hardness as calcium carbonate with reference to the calcium carbonate may be from 100 to 500, 200 to 600 limit given by the BIS. So encrustation in water supply and adverse effect on domestic users also will be the issue in terms of water quality. And we will go to the second part by understanding after drinking water issues. We will go to the agriculture, water in terms of agriculture. So agriculture also very very important. You cannot use all the water with various ranges. There is a limit also. And water quality requirement for irrigation purpose are dependent, because this is the major issue. Different types of plant, different amount of water to be used in different climatic conditions and different soil conditions. There are many factors are to be considered for the water quality issues in terms of agriculture. Important chemical criteria for the agriculture use are the salinity and sodium hazard. These two are the so important, salinity and sodium hazard. And to understand the suitability of water, there are many parameters of which that we will concentrate on total concentration of soluble salts. It depends upon the easy value. Sodium adsorption ratio (ASAR), residual sodium carbonate (RSC), and permeability index. These four factors are important for the purpose of agriculture. Normally, you see that you have different your color of the soil controls here, and you see the water where you are taking for the agriculture, drip irrigation, and it's quite interesting when you consider for the water in agriculture. A total concentration of soluble salts, it depends on easy value. The suitability of water for irrigation is mainly depends upon the amount of type of salts which is used for the purpose of agriculture. Salt concentration of irrigation water is measured by the EC. The greater the conductivity, the greater is its salt content. So this is the direct relation. If the greater conductivity, it means it is greater salt content. So EC in terms of salt, this is directly proportional to each other. The level of salt concentration in the soil has a direct bearing. Yes, that's what I said. The most influential water quality guideline on crop productivity is the water salinity hazard as measured by the electrical conductivity. And you see the soil salinity, and you look at that your water, this is saline soil, and you see that this white soil, normally this is not suggestible for the water, even though if you have water, but the water quality is not so good because of this type of rock type, or the soils leads to degrade the quality. Electrical conductivity, if it is less than 1000, it is good for good to excellent for the agriculture use. 1000 to 3000, it is injurious to good. More than 3000, it is injurious to unsatisfactory. And similarly, for sodium absorption ratio, this is the formula used for sodium absorption ratio. This is being taken as a measure of the amount of sodium, relative to the calcium and magnesium, in the water to extract for soil paste. You see, to extract from saturated soil paste, it is the ratio of sodium concentration divided by the square root of one half of the Ca plus Mg by 2 concentration. It is considered as an amount of sodium hazard to irrigation. Sodium react with the soil and reduces its permeability. So if sodium absorption ratio is high, that you see it is unsuitable. If this is the grade being used for sodium absorption ratio. If it is less than 10, it is okay, good, doubtful, and unsuitable. So if higher the sodium concentration react with the soil and reduces its permeability, the movement will be arrested, and then it will be packed completely. Hence, your water will not be, available for the agriculture use. Soil with high exchangeable sodium is very much undesirable for irrigation purpose. So we have to be very careful of the sodium absorption ratio. Coming to the residual sodium carbonate, RSC, RSC normally we call it as RSC. It is to indicate the alkalinity hazard for soil. It is used to find the suitability of water for irrigation in clay soils which has higher cation exchange capacity. RSC, if it is less than 1.2, it is probably safe and doubtful and not suitable if it is beyond 2.5. And this is being calculated by using the formula bicarbonate plus carbonate, over calcium plus magnesium. It was proposed by initially Eaton in 1950, and that it is reworked by Richards in 1955, 1954 for the assessment of residual sodium carbonate. And similarly, to the coming to the permeability index, this is very very important. It is an indicator to study the suitability of water for irrigation purpose. And you look at the animations here, if it is more permeable and then the more it permits water to flow, more permeable. Look at that, it is a loamy soil, sandy soil, loamy soil. This is a less permeable, and then the movement is going down slowly parallel to the loamy soil, not the land soil. And coming to the water movement capability in soil is influenced by long-term use of irrigation. With a higher concentration of salt is affected by sodium, calcium, magnesium and bicarbonate ions. PI, permeability index formula, has been developed in the year 1965 by the great scientist Junin classification. He has assessed the water movement and the water movement capability in the soils as the suitability of any kind of source of water. And what he has done now, the Dunin classification, he has taken sodium over bicarbonate into 100 divided by calcium, magnesium and sodium. You see the permeability index increases, what will happen to the different grade of soil. If it is a gravel, it takes only 2 minutes. If it is a sand, it takes 20 minutes to get your water. If it is a silt, that it takes very long time. Look at this animation, how fast a gravel is, that the permeability is controlled, second and third, and it takes 2 days for you to reach your water penetrate down in a clay. And this is how the permeability index, given a diagram, is proposed by Junin in 1965. If it is less than 25%, it is safe. It falls in the class 3 maximum permeability. If it is between 25 and 75, it is allowable in little permeability. And if it is more than 75, it is unsafe, and then you cannot use it for for the irrigation purpose. And coming to the classification of use for the industrial purpose, then generally industry need large quantity than the quantity of water. Hence, quality of water is also parallelly important. There are two parameters. One is scaling property and corrosion property. So these are the two major factors to be considered. This mainly depends upon the salinity and hardness. And what is the scaling? The first property, it is high level of minerals. You look at the pipe, it gets affected nearly 50% by the scaling of the salt which is present in the particular. And you look at this tap also, you see on the other sides, and you look at the shower, it is fully packed with the scaling. Scaling is the major issue, not only with respect to the agriculture and even for the domestic also. And the metal pipes become coated with harmless minerals. It is that you have to be very careful. Examples, increased level of scaling, however, can be harmful. Example, hot water heaters are the most common places scale forming. Yes, it is usually every house you can find that if the salt is there, and once in a year or once in a year you have to do the service to remove the salt. Sometimes this will leads the damage of the hot water heaters. Problem cost, reduce efficiency of your hot water heater, reduced or blocked flow of fixtures, and then leaky valves also. This all because of the pressure leads. Pressure could not be able to disseminate, and then because the pressure expected for this pipe is different than the pressure passes on this pipe, present hole. Corrosion, look at the corrosion. This is the major issues, that you cannot maintain because it is a large scale work, and you will have to keep all your materials. Corrosion is the basic problem. Electrolytic process which severely outbreaks the metal surface. You see, look at this. Corrosion is caused when water react to the metal and then they are like copper, and then what will happen? This leads to the changes in the color becoming brown. The rate of corrosion, it is also again the quality of water as a liquid flow, what it passes through the particular pipe. The corrosivity ratio, which was given by Rangarajan and Balasubramanian in 1990, if it is less than 1, it is safe, non-corrosion. If it is more than 1, if it is non-safe, unsafe for the corrosion. And problems associated with the corrosion is that deterioration of and damage to the plumbing, water damage caused by the leaks, at the staining of laundry, and bitter taste and staining and plumbing fixtures. And look at that different corrosions at different levels. You see, you have different scaling here, different corrosions here. Corrosion is high, corrosion is very high, and corrosion also, look at the and you also will find even the movement also, water movement area also looks like lot of corrosions. And here the complete pipe is damaged, and look at here, the pipe is even, that shinked because of it lost its strength because of this corrosion. The degree of either corrosivity or it is calculated by saturation index. Saturation index, it is nothing but CaCO3 is being mainly used for the saturation index. So it is another method of classifying the water to know the stability with respect to its scaling or corrosion tendency. The water with negative indices, so that is less than 0 or undersaturated with the CaCO3, and such waters have a tendency to corrode. When the saturation indices are positive, it is more than 0, the water is oversaturated CaCO3, and the such water have the tendency for scale formation. The water with saturation indices equal to 0 or equilibrium with the CaCO3, and such waters are good for industrial purpose. So this is the scale. If it is less than 0, undersaturated, tendency to corrode. If it is equal to 0, it is equilibrium, tendency for a scale formation. If it is more than 1, saturated, good for industrial use and boilers. And water for textile industry and paper and manufacturers, what is required to be considered? Color of the water, turbidity of the suspended sediments of water. There must also be limitations to be considered for hardness of water, manganese of water, and iron content of water. And control the slime formation, like algal growth has to be controlled, and various microorganisms is commonly necessary for paper mills, especially when the raw water is heavily polluted. Then you will have to take microorganism to treat the water for the textile industries. And a higher concentration of soluble organic matter are greatly regard correlation of color and turbidity. And similarly, for difficulty has also been experienced in removing iron and manganese also in the water, presence of water in the organic material for paper industry as well as to the textile industry. With this, the discussion with respect to water in terms of drinking, agriculture, and industrial is come to an end. Thank you very much.